Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, it's been a long time we didn't meet each other, so I'm really sorry for that. I wasn't there during your crucial time, that is in your unit 1, but at least I have tried my best to solve the recent question paper. Okay, so I have finished it half. It was supposed to be finish it finish in full. Okay, I was supposed to finish it completely, but you know, I have some limitation. uh, okay, so today we're gonna try to solve Pearson Edexcel International Advanced Level, okay, IAL, in other words, Chemistry Advanced Subsidiary Unit 2, Application of Core Principle of Chemistry, okay, Unit 2, and the recent question paper of IAL Unit 2. Okay, so fellas, this is Chemaddicts to the solution. Okay, so let's try to solve this question. So here let us read question number 1. So in question number 1 it says, how many molecular ion peaks are in the mass spectrum of 1,2-dichloroethane. Okay, so they have asked us about molecular ion peak that would be present in the mass spectrum of 1,2-dichloroethane. Okay, so assume the only isotopes are present here are H, that is hydrogen. There is only one isotope of hydrogen, then carbon, then chlorine. One is chlorine 35 and another one is chlorine 37. Okay, so in here, so they have asked us to find the molecular ion peaks. Okay, they have asked us about the molecular ion peaks, the expected molecular ion peaks that we would find from this mass spectrum. Okay, so before starting, let us know one thing, that is, here they have asked us about the molecular ion peak, okay, not fragmented ion peak. So there is a difference between molecular ion peak and fragmented ion peaks. Okay, so here that we need to know is molecular. If we break a molecular ion, okay, if we want to break a molecular ion, we will end up getting fragmented ion plus free radical. Okay, so that's the simple formula for that. Okay, so in here there is a difference between molecular ion and fragmented ion. Okay, so the fragmented ion is the one that is formed from the molecular ion. Okay, so they are not the same thing, they are different. So in here they have asked about the molecular ion peak. Okay, so in here more specifically, this molecular ion peak, this molecular ion can be called molecular cations. Okay, since molecular cations are formed, molecular cations. Okay, molecular cations. So here molecular cations are formed. Here molecular cations are formed. Okay, why? When an electron is removed from a molecule. So molecular cations are formed. More specifically, molecular cations are formed since an electron is removed from a molecule. Okay, so here, before answering this question, let us now draw the structure of the molecular ions. Okay, so here let us draw the possible structure of molecular ion. Okay, let us try. So now let us try to draw the molecular structure of um, what molecular ion structure. Let us now draw the molecular ion structure. Molecular ion. Okay, molecular ion. Okay, given that here the name of the what the name of the compound is 1,2-dichloroethane. Ethane. Okay, 1,2-dichloroethane. So here, since we are assuming that the isotopes are present, assuming the only isotopes are present is H hydrogen 1, then carbon 12. Okay, carbon 12, hydrogen 1, carbon 12, chlorine 35 and chlorine 37. Okay, these specific isotopes are present over here. So we need to draw. At first, let us draw the molecular structure of this possible molecular structure of this compound using these isotopes. Okay, so here are many possible combination. So now let us try to find the possible combination of molecular ion peaks. Okay, molecular ions. Okay, so the first possible combination is this. So here we have chlorine. By the way, we all know about the structure of ethene. So chloroethane will be similar to ethane. Okay, so let's draw. So at first we are drawing the structure of ethane. Okay, ethane, not ethene. They are different. Okay, one is alkene and another one is alkene. Okay, so here we all know that here we have only one isotope of hydrogen, that is hydrogen 1. So here it is hydrogen 1, this should be hydrogen 1. All of the hydrogen here will be 1, isotope 1. Okay, hydrogen 1. The isotope of hydrogen here is 1 in each case. Okay, so here we also know that the only isotope of carbon present here is 12. Here this is carbon 12 and this is carbon 12. Okay, so here as you can see that the only difference, as we can see that here only chlorine makes the difference. Okay, here since we have two possible isotopes present over here, so we're gonna get different molecular ions. Okay, so the one possible molecular ion is this should be chlorine 35 and this should be chlorine 35. Okay, so here since one electron is removed from this molecule, so it would be a cation. Okay, so here we have find out one possible molecular ion. Let us try to find another possible cation. Okay, so if we use the combination of these two things here, chlorine 35 and chlorine 37, we're gonna able to find other possible molecules of molecular ion, other possible molecular ions. Okay, this would be as it is, since there is only one isotope of hydrogen and carbon is present once again. Okay, so as you can see here, the only difference would be the isotopes of chlorine. Okay, and other things would be the same. That's it. So here before we have used chlorine 35 and this is chlorine 35. Where is my eraser? Here is my eraser. now it's cool. Okay, so here before we have used chlorine 35, chlorine 35, okay, on this molecular ion. So we have find this by chlorine 35, chlorine 35. We have used a combination chlorine 35, chlorine 35. Here we gonna change a little bit. Here we gonna write chlorine 35. Here we gonna put chlorine 35 atom over here on this carbon, and we gonna put chlorine 37 on this carbon. Okay, now we gonna get another molecular ion. Okay, so now as far we have find two molecular ions. Okay, two possible molecular ions. So now let us find the other one, other two. So here the other things would be different. Sorry, all the things would be same over here since they have one isotope. Okay, fine. So here we have used 35 35 chlorine 35 chlorine 35, this combination. We have used this combination chlorine 35 chlorine 35. In here we have used this combination chlorine 35 chlorine 37. Now we're gonna use chlorine 37 chlorine 37. That's it. This is how we're gonna do. Okay, and this is the last molecular ion of this compound. Okay, so since here only variable over here is chlorine, since the only variable over here is chlorine. Okay, so chlorine has got the only variable isotope. So since two chlorine isotopes are present, so there would be three possible structure of molecular ion. Okay, so three molecular ion would be present over here. So since there is no variation in hydrogen or carbon, since they have only one isotope, so we will end up getting three possible molecular ion. Okay, three possible molecular ion. Okay, molecular ions, ignore the spelling. Okay, three possible molecular ions. Well fellas, by this meantime you are about to guess which should be the answer. Okay, so now let's find the answer. Oops, not this one, I guess. Yes, so in here the only isotope present here is this or this. Okay, so here they have given us the option. So here this should be the answer, B. Okay, so in here B is the answer to this question. So before we have seen that three possible molecular ion peaks would be detected since three molecular cations are possible for this particular compound. Since three possible molecular cations, as how should I say? Okay, since three molecular cations are possible for this particular compound, so this should be the answer. Okay, so fellas, I hope that you have understood the question as well as the solution. So if you have missed anything or confused, messed up, or if you have any confusion regarding this concept or whatever, please let me know in the comment section. Okay, so I'll be always there helping you fellas. So sorry for my previous behavior, I wasn't there during your crucial time, but I will try my level best to complete this question paper. Okay, since it is really hard for me to accomplish, to solve this question paper, to accomplish this mission. Okay, so it's a mission to me. Okay, because we have lots of questions to do, lots of problems to solve. So I will try my level best to solve this whole question paper, whole bunch of these problems. I know that you have really many problems regarding this problem, many problems regarding this question paper. I will try my level best to solve this question paper completely. Okay, so until then, stay cool, stay awesome, and as always, peace with chemistry. And yeah, one thing, best of luck for your exam.